Saturn is the sixth planet from the Sun and the second largest in the solar system, after Jupiter. It is a gas giant with an average radius of about 9.5 times that of Earth. It has only 1/8 the average density of Earth, however. With its larger volume, Saturn is over 95 times more massive. Saturn's interior is most likely composed of a core of ironical and rock silicon and oxygen compounds. Its core is surrounded by a deep layer of metallic hydrogen, an intermediate layer of liquid hydrogen and liquid helium, and finally, a gaseous outer layer. Saturn has a pale yellow hue due to ammonia crystals in its upper atmosphere. An electrical current within the metallic hydrogen layer is thought to give rise to Saturn's planetary magnetic field, which is weaker than Earth's, but which has a magnetic moment 580 times that of Earth due to Saturn's larger size. Saturn's magnetic field strength is around 1/20th of Jupiter's. The outer atmosphere is generally bland and lacking in contrast, although long-lived features can appear. Wind speeds on Saturn can reach 1,800 kilometers per hour, 1,100 miles per hour, 500 meters per second, higher than on Jupiter but not as high as on Neptune. The planet's most notable feature is its prominent ring system, which is composed mainly of ice particles, with a smaller amount of rocky debris and dust. At least 83 moons are known to orbit Saturn, of which 53 are officially named. This does not include the hundreds of moonlets in its rings. Titan, Saturn's largest moon and the second largest in the solar system, is larger than the planet Mercury, although less massive, and is the only moon in the solar system to have a substantial atmosphere. Saturn is named after the Roman god of wealth and agriculture and father of Jupiter. Its astronomical symbol has been traced back to the Greek Oxyrhynchus Papyri, where it can be seen to be a Greek kappa-rho with a horizontal stroke, as an abbreviation for Cronus, the Greek name for the planet. It later came to look like a lowercase Greek eta, with the cross added at the top in the 16th century to Christianize this pagan symbol. The Romans named the seventh day of the week Saturday, Sterni de Saturn's day, for the planet Saturn. Saturn is a gas giant composed predominantly of hydrogen and helium. It lacks a definite surface, though it is likely to have a solid core. Saturn's rotation causes it to have the shape of an oblate spheroid. That is, it is flattened at the poles and bulges at its equator. Its equatorial and polar radii differ by almost 10%, 60,268 kilometers versus 54,364 kilometers. Jupiter, Uranus, and Neptune, the other giant planets in the solar system, are also oblate but to a lesser extent. The combination of the bulge and rotation rate means that the effective surface gravity along the equator, 8.96 meters per second squared, is 74% of what it is at the poles and is lower than the surface gravity of Earth. However, the equatorial escape velocity of nearly 36 kilometers per second is much higher than that of Earth. Saturn is the only planet of the solar system that is less dense than water, about 30% less. Although Saturn's core is considerably denser than water, the average specific density of the planet is 0.69 grams per cubic centimeters due to the atmosphere. Jupiter has 318 times Earth's mass, and Saturn is 95 times Earth's mass. Together, Jupiter and Saturn hold 92% of the total planetary mass in the solar system. Despite consisting mostly of hydrogen and helium, most of Saturn's mass is not in the gas phase, because hydrogen becomes a non-ideal liquid when the density is above 0.01 grams per cubic centimeters, which is reached at a radius containing 99.9% of Saturn's mass. The temperature, pressure, and density inside Saturn all rise steadily toward the core, which causes hydrogen to be a metal in the deeper layers. Standard planetary models suggest that the interior of Saturn is similar to that of Jupiter, having a small rocky core surrounded by hydrogen and helium, with trace amounts of various volatiles. Analysis of the distortion shows that Saturn is substantially more centrally condensed than Jupiter and therefore contains a significantly larger amount of material denser than hydrogen near its center. Saturn's central regions contain about 50% hydrogen by mass, while Jupiter's contain approximately 67% hydrogen. This core is similar in composition to Earth, but is more dense. The examination of Saturn's gravitational moment, in combination with physical models of the interior, has allowed constraints to be placed on the mass of Saturn's core. In 2004, scientists estimated that the core must be 9 to 22 times the mass of Earth, which corresponds to a diameter of about 25,000 kilometers. However, measurements of Saturn's ring suggest a much more diffuse core with a mass equal to about 17 Earths and a radius equal to around 60% of Saturn's entire radius. This is surrounded by a thicker liquid metallic hydrogen layer, followed by a liquid layer of helium-saturated molecular hydrogen that gradually transitions to a gas with increasing altitude. The outermost layer spans 1,000 kilometers and consists of gas. Saturn has a hot interior, reaching 11,700 degrees Celsius at its core, and radiates 2.5 times more energy into space than it receives from the Sun. Jupiter's thermal energy is generated by the Kelvin-Helmholtz mechanism of slow gravitational compression, but such a process alone may not be sufficient to explain heat production for Saturn because it is less massive. An alternative or additional mechanism may be generation of heat through the raining out of droplets of helium deep in Saturn's interior. As the droplets descend through the lower density hydrogen, the process releases heat by friction and leaves Saturn's outer layers depleted of helium. These descending droplets may have accumulated into a helium shell surrounding the core. Rainfalls of diamonds have been suggested to occur within Saturn, as well as in Jupiter and ice giants Uranus and Neptune. The outer atmosphere of Saturn contains 96.3% molecular hydrogen and 3.25% helium by volume. The proportion of helium is significantly deficient compared to the abundance of this element in the Sun. The quantity of elements heavier than helium metallicity is not known precisely, but the proportions are assumed to match the primordial abundances from the formation of the solar system. The total mass of these heavier elements is estimated to be 19 to 31 times the mass of the Earth, with a significant fraction located in Saturn's core region. Trace amounts of ammonia, acetylene, ethane, propane, phosphine, and methane have been detected in Saturn's atmosphere. The upper clouds are composed of ammonia crystals, while the lower level clouds appear to consist of either ammonium hydrosulfide and foreshore water. Ultraviolet radiation from the Sun causes methane photolysis in the upper atmosphere, leading to a series of hydrocarbon chemical reactions with the resulting products being carried downward by eddies and diffusion. This photochemical cycle is modulated by Saturn's annual seasonal cycle. Saturn's atmosphere exhibits a banded pattern similar to Jupiter's, but Saturn's bands are much fainter and are much wider near the equator. The nomenclature used to describe these bands is the same as on Jupiter. Saturn's finer cloud patterns were not observed until the flybys of the Voyager spacecraft during the 1980s. Since then, Earth-based telescopy has improved to the point where regular observations can be made. The composition of the clouds varies with depth and increasing pressure. In the upper cloud layers, with the temperature in the range 100 to 160 kelvins and pressures extending between 0.52 bar, the clouds consist of ammonia ice. Water ice clouds begin at a level where the pressure is about 2.5 bar and extend down to 9.5 bar, where temperatures range from 185 to 270 kelvins. Intermixed in this layer is a band of ammonium hydrosulfide ice, lying in the pressure range 36 bar with temperatures of 190 to 235 kelvins. Finally, the lower layers, where pressures are between 10 and 20 bar and temperatures are 270 to 330 kelvins, contains a region of water droplets with ammonia in aqueous solution. Saturn's usually bland atmosphere occasionally exhibits long-lived ovals and other features common on Jupiter. In 1990, the Hubble Space Telescope imaged an enormous white cloud near Saturn's equator that was not present during the Voyager encounters, and in 1994 another smaller storm was observed. The 1990 storm was an example of a great white spot, a unique but short-lived phenomenon that occurs once every Saturnian year, roughly every 30 Earth years, around the time of the Northern Hemisphere's summer solstice. Previous great white spots were observed in 1876, 1903, 1933, and 1960, with the 1933 storm being the most famous. If the periodicity is maintained, another storm will occur in about 2020. The winds on Saturn are the second fastest among the solar system's planets after Neptune's. Voyager data indicate peak easterly winds of 500 meter-seconds 1800 kilometers per hour. In images from the Cassini spacecraft during 2007, Saturn's northern hemisphere displayed a bright blue hue, similar to Uranus. The color was most likely caused by Rayleigh scattering. Thermography has shown that Saturn's south pole has a warm polar vortex, the only known example of such a phenomenon in the solar system. Whereas temperatures on Saturn are normally 185 grads Celsius, temperatures on the vortex often reach as high as 122 grads Celsius, suspected to be the warmest spot on Saturn. A persisting hexagonal wave pattern around the north polar vortex in the atmosphere at about 78 degrees north was first noted in the Voyager images. The sides of the hexagon are each about 14,500 kilometers 9,000 miles long, which is longer than the diameter of the Earth. The entire structure rotates with a period of 1039 the same period as that of the planet's radio emissions, which is assumed to be equal to the period of rotation of Saturn's interior. The hexagonal feature does not shift in longitude like the other clouds in the visible atmosphere. The pattern's origin is a matter of much speculation. Most scientists think it is a standing wave pattern in the atmosphere. Polygonal shapes have been replicated in the laboratory through differential rotation of fluids. Past imaging of the south polar region indicates the presence of a jet stream, but no strong polar vortex, nor any hexagonal standing wave. NASA reported in November 2006 that Cassini had observed a hurricane-like storm locked to the South Pole that had a clearly defined eye wall. Eye wall clouds had not previously been seen on any planet other than Earth. For example, images from the Galileo spacecraft did not show an eye wall in the Great Red Spot of Jupiter. The South Pole storm may have been present for billions of years. This vortex is comparable to the size of Earth, and it has winds of 550 kilometers per hour. Cassini observed a series of cloud features found in northern latitudes, nicknamed the String of Pearls. These features are cloud clearings that reside in deeper cloud layers. Saturn has an intrinsic magnetic field that has a simple, symmetric shape, a magnetic dipole. Its strength at the equator 0.2 Gauss microtslas is approximately 1/20th of that of the field around Jupiter and slightly weaker than Earth's magnetic field. As a result, Saturn's magnetosphere is much smaller than Jupiter's. When Voyager 2 entered the magnetosphere, the solar wind pressure was high and the magnetosphere extended only 19 Saturn radii, or 1.1 million kilometers, 712,000 miles, although it enlarged within several hours and remained so for about 3 days. Most probably, the magnetic field is generated similarly to that of Jupiter by currents in the liquid metallic hydrogen layer called a metallic hydrogen dynamo. This magnetosphere is efficient at deflecting the solar wind particles from the Sun. The Moon Titan orbits within the outer part of Saturn's magnetosphere and contributes plasma from the ionized particles in Titan's outer atmosphere. Saturn's magnetosphere, like Earth's, produces aurora. The average distance between Saturn and the Sun is over 1.4 billion kilometers, 9 astronomical units. With an average orbital speed of 9.68 kilometers per second, it takes Saturn 10,759 Earth days, or about 29.12 years, to finish one revolution around the Sun. As a consequence, it forms a near 5 to mean motion resonance with Jupiter. The elliptical orbit of Saturn is inclined 2.48 degrees relative to the orbital plane of the Earth. The perihelion and aphelion distances are, respectively, 9.195 and 9.957 astronomical units, on average. The visible features on Saturn rotate at different rates depending on latitude, and multiple rotation periods have been assigned to various regions, as in Jupiter's case. Astronomers use 3 different systems for specifying the rotation rate of Saturn. System 1 has a period of 10 days, 14 minutes, 0 seconds, 844.3 degrees per day, and encompasses the equatorial zone, the south equatorial belt, and the north equatorial belt. The polar regions are considered to have rotation rates similar to System 1. All other Saturnian latitudes, excluding the north and south polar regions, are indicated as System 2 and have been assigned a rotation period of 10 days, 38 minutes, 25.4 seconds, 810.76 degrees per day. System 3 refers to Saturn's internal rotation rate. Based on radio emissions from the planet detected by Voyager 1 and Voyager 2, System 3 has a rotation period of 10 days, 39 minutes, 22.4 seconds, 810.8 degrees per day. System 3 has largely superseded System 2. A precise value for the rotation period of the interior remains elusive. While approaching Saturn in 2004, Cassini found that the radial rotation period of Saturn had increased appreciably to approximately 10 days, 45 minutes, 45 seconds, 36. An estimate of Saturn's rotation as an indicated rotation rate for Saturn as a whole, based on a compilation of various measurements from the Cassini, Voyager, and Pioneer probes, is 1032-35. Studies of the planets yield a rotation period of 1033-38 onum 52s onum 19s. In March 2007, it was found that the variation of radio emissions from the planet did not match Saturn's rotation rate. This variance may be caused by geyser activity on Saturn's moon Enceladus. The water vapor emitted into Saturn's orbit by this activity becomes charged and creates a drag upon Saturn's magnetic field, slowing its rotation slightly relative to the rotation of the planet. An apparent oddity for Saturn is that it does not have any known Trojan asteroids. These are minor planets that orbit the Sun at the stable Lagrangian points, designated L4 and L5, located at 60 degrees angles to the planet along its orbit. Trojan asteroids have been discovered from Mars, Jupiter, Uranus, and Neptune. Orbital resonance mechanisms, including secular resonance, are believed to be the cause of the missing Saturnian Trojans. Saturn has 83 known moons, 53 of which have formal names. In addition, there is evidence of dozens to hundreds of moonlets with diameters of 4,500 meters in Saturn's rings, which are not considered to be true moons. Titan, the largest moon, comprises more than 90% of the mass in orbit around Saturn, including the rings. Saturn's second largest moon, Rhea, may have a tenuous ring system of its own, along with a tenuous atmosphere. Many of the other moons are small. 34 are less than 10 kilometers in diameter, and another 14 between 10 and 50 kilometers in diameter. Traditionally, most of Saturn's moons have been named after Titans of Greek mythology. Titan is the only satellite in the solar system with a major atmosphere in which a complex organic chemistry occurs. It is the only satellite with hydrocarbon lakes. On 6 June 2013, scientists at the EIXIC reported the detection of polycyclic aromatic hydrocarbons in the upper atmosphere of Titan, a possible precursor for life. On 23 June 2014, NASA claimed to have strong evidence that nitrogen in the atmosphere of Titan came from materials in the Oort cloud associated with comets, and not from the materials that formed Saturn in earlier times. Saturn's moon Enceladus, which seems similar in chemical makeup to comets, has often been regarded as a potential habitat for microbial life. Evidence of this possibility includes the satellite's salt-rich particles having an ocean-like composition that indicates most of Enceladus's expelled ice comes from the evaporation of liquid salt water. A 2015 flyby by Cassini through a plume on Enceladus found most of the ingredients to sustain life forms that live by methanogenesis. In April 2014, NASA scientists reported the possible beginning of a new moon within the ring, which was imaged by Cassini on 15 April 2013. Saturn is probably best known for the system of planetary rings that makes it visually unique. The rings extend from 6,630 to 120,700 kilometers, 4,120 to 75,000 miles outward from Saturn's equator, and average approximately 20 meters, 66 feet in thickness. They are composed predominantly of water ice, with trace amounts of Tholen impurities and a peppered coating of approximately 7% amorphous carbon. The particles that make up the rings range in size from specks of dust up to 10 meters. While the other gas giants also have ring systems, Saturn's is the largest and most visible. There are two main hypotheses regarding the origin of the rings. One hypothesis is that the rings are remnants of a destroyed moon of Saturn. The second hypothesis is that the rings are a leftover from the original nebular material from which Saturn was formed. Some ice in the ring comes from the moon Enceladus's geysers. The water abundance of the rings varies radially, with the outermost ring being the most pure in ice water. This abundance variance may be explained by meteor bombardment. Beyond the main rings, at a distance of 12 million kilometers from the planet, is the sparse Phoebe ring. It is tilted at an angle of 27 degrees to the other rings and, like Phoebe, orbits in retrograde fashion. Some of the moons of Saturn, including Pandora and Prometheus, act as shepherd moons to confine the rings and prevent them from spreading out. Pan and Atlas cause weak, linear density waves in Saturn's rings that have yielded more reliable calculations of their masses. The observation and exploration of Saturn can be divided into three phases. The first phase is ancient observations, such as with the naked eye, before the invention of modern telescopes. The second phase began in the 17th century, with telescopic observations from Earth, which improved over time. The third phase is visitation by space probes, in orbit or on flyby. In the 21st century, telescopic observations continue from Earth, including Earth orbiting observatories like the Hubble Space Telescope and, until its 2017 retirement, from the Cassini orbiter around Saturn. Saturn has been known since prehistoric times, and in early recorded history it was a major character in various mythologies. Babylonian astronomers systematically observed and recorded the movements of Saturn. In ancient Greek, the planet was known as Phanon, and in Roman times it was known as the star of Saturn. In ancient Roman mythology, the planet Phanon was sacred to this agricultural god, from which the planet takes its modern name. The Romans considered the god Saturnus the equivalent of the Greek god Cronus. In modern Greek, the planet retains the name Cronus. Cronos. The Greek scientist Ptolemy based his calculations of Saturn's orbit on observations he made while it was in opposition. In Hindu astrology, there are 9 astrological objects, known as navagrahas. Saturn is known as Shani and judges everyone based on the good and bad deeds performed in life. Ancient Chinese and Japanese culture designated the planet Saturn as the Earth's star. This was based on 5 elements which were traditionally used to classify natural elements. In ancient Hebrew, Saturn is called Shabbathai. Its angle is Cassiel. Its intelligence or beneficial spirit is Agil Hebrew, Romanized, Agiel, and its darker spirit demon is Ezel Hebrew, Romanized, Zazel. Zazel has been described as a great angel invoked in Solomonic magic, who is effective in love conjurations. In Ottoman Turkish, Urdu, and Malay, the name of Zazel is Zul, derived from the Arabic language Arabic, Romanized, Zuhal. Saturn's rings require at least a 15 millimeters diameter telescope to resolve and thus were not known to exist until Christian-Huygens saw them in 1655 and published about this in 1659. Galileo, with his primitive telescope in 1610, incorrectly thought of Saturn's appearing not quite round as two moons on Saturn's sides. It was not until Huygens used greater telescopic magnification that this notion was refuted, and the rings were truly seen for the first time. Huygens also discovered Saturn's moon Titan. Giovanni Domenico Cassini later discovered four other moons: Aepitus, Rhei, Tethys, and Dian. In 1675, Cassini discovered the gap now known as the Cassini division. No further discoveries of significance were made until 1789, when William Herschel discovered two further moons, Mimas and Enceladus. The irregularly shaped satellite Hyperion, which has a resonance with Titan, was discovered in 1848 by a British team. In 1899, William Henry Pickering discovered Phoebe, a highly irregular satellite that does not rotate synchronously with Saturn as the larger moons do. Phoebe was the first such satellite found, and it takes more than a year to orbit Saturn in a retrograde orbit. During the early 20th century, research on Titan led to the confirmation in 1944 that it had a thick atmosphere, a feature unique among the solar system's moons. Pioneer 11 made the first flyby of Saturn in September 1979, when it passed within 20,000 kilometers of the planet's cloud tops. Images were taken of the planet and a few of its moons, although their resolution was too low to discern surface detail. The spacecraft also studied Saturn's rings, revealing the thin ring and the fact that dark gaps in the rings are bright when viewed at high phase angle towards the Sun, meaning that they contain fine light scattering material. In addition, Pioneer 11 measured the temperature of Titan. In November 1980, the Voyager 1 probe visited the Saturn system. It sent back the first high-resolution images of the planet, its rings, and satellites. Surface features of various moons were seen for the first time. Voyager 1 performed a close flyby of Titan, increasing knowledge of the atmosphere of the moon. It proved that Titan's atmosphere is impenetrable in visible wavelengths. Therefore, no surface details were seen. The flyby changed the spacecraft's trajectory out from the plane of the solar system. Almost a year later, in August 1981, Voyager 2 continued the study of the Saturn system. More close-up images of Saturn's moons were acquired, as well as evidence of changes in the atmosphere and the rings. Unfortunately, during the flyby, the probe's turnable camera platform stuck for a couple of days and some planned imaging was lost. Saturn's gravity was used to direct the spacecraft's trajectory towards Uranus. The probes discovered and confirmed several new satellites orbiting near or within the planet's rings, as well as the small Maxwell gap, a gap within its ring, and Keeler gap, a 42 kilometers wide gap in the ring. The Cassini-Huygens space probe entered orbit around Saturn on 1 July 2004. In June 2004, it conducted a close flyby of Phoebe, sending back high-resolution images and data. Cassini's flyby of Saturn's largest moon, Titan, captured radar images of large lakes and their coastlines with numerous islands and mountains. The orbiter completed 2 Titan flybys before releasing the Huygens probe on 25 December 2004. Huygens descended onto the surface of Titan on 14 January 2005. Starting in early 2005, scientists used Cassini to track lightning on Saturn. The power of the lightning is approximately 1,000 times that of lightning on Earth. In 2006, NASA reported that Cassini had found evidence of liquid water reservoirs no more than tens of meters below the surface that erupt in geysers on Saturn's moon Enceladus. These jets of icy particles are emitted into orbit around Saturn from vents in the moon's south polar region. Over 100 geysers have been identified on Enceladus. In May 2011, NASA scientists reported that Enceladus is emerging as the most habitable spot beyond Earth in the solar system for life as we know it. Cassini photographs have revealed a previously undiscovered planetary ring outside the brighter main rings of Saturn and inside the Gandu rings. The source of this ring is hypothesized to be the crashing of a meteoroid off Janus and Epimetheus. In July 2006, images were returned of hydrocarbon lakes near Titan's North Pole, the presence of which were confirmed in January 2007. In March 2007, hydrocarbon seas were found near the North Pole, the largest of which is almost the size of the Caspian Sea. In October 2006, the probe detected an 8,000 kilometers diameter cyclone-like storm with an eye wall at Saturn's south pole. From 2004 to November 2009, the probe discovered and confirmed 8 new satellites. In April 2013, Cassini sent back images of a hurricane at the planet's north pole 20 times larger than those found on Earth, with winds faster than 530 kilometers per hour, 330 miles per hour. On 15 September 2017, the Cassini-Huygens spacecraft performed the grand finale of its mission. A number of passes through gaps between Saturn and Saturn's inner rings. The atmospheric entry of Cassini ended the mission. The continued exploration of Saturn is still considered to be a viable option for NASA as part of their ongoing New Frontiers program of missions. NASA previously requested for plans to be put forward for a mission to Saturn that included the Saturn Atmospheric Entry Probe and possible investigations into the habitability and possible discovery of life on Saturn's moons Titan and Enceladus by Dragonfly. Saturn is the most distant of the 5 planets easily visible to the naked eye from Earth, the other 4 being Mercury, Venus, Mars, and Jupiter. Uranus, and occasionally 4 Vesta, are visible to the naked eye in dark skies. Saturn appears to the naked eye in the night sky as a bright, yellowish point of light. The mean apparent magnitude of Saturn is 0.46 with a standard deviation of 0.34. Most of the magnitude variation is due to the inclination of the ring system relative to the Sun and Earth. The brightest magnitude, 0.55, occurs near in time to when the plane of the rings is inclined most highly, and the faintest magnitude, 1.17, occurs around the time when they are least inclined. It takes approximately 29.5 years for the planet to complete an entire circuit of the ecliptic against the background constellations of the zodiac. Most people will require an optical aid, very large binoculars, or a small telescope that magnifies at least 30 times to achieve an image of Saturn's rings in which clear resolution is present. When Earth passes through the ring plane, which occurs twice every Saturnian year, roughly every 15 Earth years, the rings briefly disappear from view because they are so thin. Such a disappearance will next occur in 2025, but Saturn will be too close to the Sun for observations. Saturn and its rings are best seen when the planet is at, or near, opposition, the configuration of a planet when it is at an elongation of 180 degrees, and thus appears opposite the Sun in the sky. A Saturnian opposition occurs every year, approximately every 378 days, and results in the planet appearing at its brightest. Both the Earth and Saturn orbit the Sun on eccentric orbits, which means their distances from the Sun vary over time, and therefore so do their distances from each other, hence varying the brightness of Saturn from one opposition to the next. Saturn also appears brighter when the rings are angled such that they are more visible. For example, during the opposition of 17 December 2002, Saturn appeared at its brightest due to a favorable orientation of its rings relative to the Earth, even though Saturn was closer to the Earth and Sun in late 2003. From time to time, Saturn is occulted by the Moon, that is, the Moon covers up Saturn in the sky. As with all the planets in the solar system, occultations of Saturn occur in seasons. Saturnian occultations will take place monthly for about a 12-month period, followed by about a 5-year period in which no such activity is registered. The Moon's orbit is inclined by several degrees relative to Saturn's, so occultations will only occur when Saturn is near one of the points in the sky where the two planes intersect. Both the length of Saturn's year and the 18.6 Earth-year nodal precession period of the Moon's orbit influence the periodicity.